Okay, let's discuss question 5. So in this question, you have to do certain measurements, make some measurements in order for you to find what is the wavelength of the light source. So this is D, the separation between the two slits, and this here is your L, 1.2 meters. But delta Y is not given. So delta Y will be the fringe separation. Okay, what normally students will do will be they'll take the distance from here to here, right? So extend the line until it touches your ruler, and then take the next subsequent line until it touches the ruler, and then measure delta Y. Okay, don't do that. What you should do will be basically take from different orders. So take from here to here. You will show better experimental skills, right? From this point to this point. Or alternative, you can actually take from the minimum, from this point, minimum, to this point, the minimum. Because fringe separation will be the distance between adjacent maximum or the distance between adjacent minimum. So try to take it as large as possible, right? To show that you have better experimental skills, right? As compared to taking the adjacent maximum or between the distance between adjacent minimum. So what you do will be, if you measure from this point, you measure that the first point is 3.7 cm. And when you extend to this point, this minimum, it is basically 8.8 cm. So the distance between them is, if I minus, right, 8.7, 8.8 minus 3.7, what get the distance between this order minimum to this order minimum, the total distance is 5.1 centimeter. So this is equal to 1 delta Y. You see 1, 2, 3, 4, 5, 6, 7 delta Y. So 7 delta Y is equal to 5.1 centimeter. So therefore delta Y will be 5.1 divided by 7 centimeters. So this will add up to about 0.728 centimeters, right? So this will be giving you higher accuracy as compared to taking between adjacent maximum. Okay, now that we have found delta Y, we can find lambda using this formula. Delta Y is equal as lambda L divided by D. So what is lambda? Lambda is actually delta Y times D divided by L. So delta Y is 0.728 centimeter, change it to meters, times D. So D is 0.24 millimeter. Change it to meters, and L is 1.2 meters. So using our calculator, we can find lambda to be 1.46 times 10 to the power minus 6 meters. So often in your exam, you'll be given cases where they will test you on your experimental skills. Okay, for part B, the experiment was repeated with polarized light such that light passing through one slit is polarized perpendicular to the light passing through the other slit. So using the principle of superposition, explain what will happen to the interference pattern above. Okay, let's describe, right? What happens is, principle of superposition is basically when the light source comes out from S1, okay, and when the light source comes out from S2. So using principle of superposition, that means the electric field from S1, that's called E1, is going to add up with the electric field of E2 using vector addition. Both electric fields are vector. So to find the resultant electric field is basically E1 plus E2. That's when you get constructive interference. If they are out of phase, then the resultant will be E1 minus E2. That's when you get destructive interference. So for us to see constructive interference, the two waves must be in the same plane of polarization. So what happens if S1 is emitted along the vertical plane, whereas S2 is emitted along the horizontal plane, along the horizontal. So how do these two electric fields add up together? Do they experience constructive interference or do they experience destructive interference? So the answer will be they don't. All right, they don't. So they are not going to cause constructive interference, neither are they going to cause destructive interference. So in this case, what happens to your pattern? Your pattern will just disappear. Right? So on part B, if the two waves are polarized such that they are right angles with respect to one another, the interference pattern would disappear.